Right, so thanks you guys for all getting here this morning. You have your quiz 1 is due. You can just put it in your folder. If you hear from anybody else in class and they're freaking out about their quiz being due, tell them that they can bring it in later today if the snow clears up, or they can email it to me. As long as I get it somehow today, that's fine. Quiz 2 it's coming up. The due date is going to be Wednesday next week, but you can do it any time. You have it now. It's at the front of your packet. So quiz 2 is your memorized rules. It's like a self quiz. Do you know all the derivative and antiderivative rules? Okay. And you even have the answers. So like you take the quiz, you check the answers. If you didn't get them all right, take the quiz again. You have 2 more copies. Okay. Just do it as many times as you need to until you get a 100 and then hand it in. Got it? Okay, so that's due Wednesday, but you can start doing it anytime. You know everything you need to know. And then project 2 is assigned today, so I'll hand those out while I'm thinking of it. Okay, so project 2, just handed it out. It is going to be due on the 12th, so that's a week from today. Okay, so let's look at class 5. We're going to talk about differential equations. In this class, we're going to solve differential equations and initial value problems, including problems related to motion. So differential equation is just an equation that involves derivatives. A simple example, a satellite that has a constant velocity of 80 meters per second. If we want to let S of t represent the position of the satellite, right? S of t is position, then ds dt would be what? What's the derivative of position? Velocity, yep. So I could write ds dt equals 80. The rate of change of position is 80 because we know that's the velocity. So it's a simple differential equation because there's a derivative in that equation. Differential equations can get much more complex. For example, y double prime minus y prime minus 12y equals 0. In English, we're looking for a function y such that the second derivative of y minus the first derivative of y minus 12 times the original function equals 0. Any thoughts on what kind of function might work? What kind of function could you... So if you have to be able to subtract these and get 0, then y double prime and y prime and some multiple of y, they all need to be like terms. Yeah, okay, so here's a guess, right? If we guess y equals x squared, then y prime would be 2x and y double prime would be 2, right? All right, so let's plug in and see if this is true. Y double prime minus y prime minus 12y equals 0. I'm going to replace y double prime with a 2, replace y prime with a 2x, replace y with an x squared. Does that equal 0? All the time for all x's? Has to always be true. That a solution is a function that would make that always true. E to something might work because we need to be able to take those 3 terms and combine them, right? They need to be like terms so that you can add them up and get 0 or subtract them and get 0. All right, so that didn't work. I'm going to give you a solution and then we'll prove that it works. So y equals e to the negative 3x turns out to be a solution. So let's check. So, so what's y prime? negative 3 e to the negative 3x. And y double prime? Great. All right, let's see if we plug those in, do we get a true statement with the differential equation? Y double prime minus y prime minus 12y, does that equal 0? Always, right? For all possible values. All right, so y double prime is 9e to the negative 3x. Subtract y prime, so I'm going to take away minus negative 3e to the negative 3x, and then subtract 12 times y e to the negative 3x. Do I get 0? Yes, those are like terms. And I have combined the first two, you get 12 e to the negative 3x minus 12 e to the negative 3x. That is a true equation. Y equals 0 is also a solution. Yep. Good. So this is our solution, y equals e to the negative 3x. And we just showed that it is. So there's a whole course on these. What do you think the course is called? Differential equations, good. But we're mostly going to stick to simpler differential equations. For now, our differential equations are all going to have the form dy dx equals some stuff involving x. Solving a differential equation means finding a formula in the form of y equals some stuff in terms of x. You're looking for a function that makes the differential equation true. So here's a simple differential equation, dy dx equals cosine x minus 1. So we're looking for a solution, right? So I'm looking for a function y whose derivative is cosine x minus 1. What do you think? Y would be close? Yeah, sine x minus x. And then dy dx would be cosine x minus 1. How many solutions are there? Yeah, because I could put plus c. Any function with a plus c will have the dy dx as cosine x minus 1. So the solutions are related in that they are vertical shifts of each other. They just differ by a constant. So solutions. C could be any possible value in the whole real number line. So it could be sine x minus 7. Could be sine x minus x plus 18. Yep, so C can definitely be negative. Yep. So basically this is your textbook is calculus, single variable, right? This is real variable calculus. We will never deal with imaginary numbers in this class. There is a course that deals with calculus when you are in the complex plane called complex analysis. Probably take it in another 2 or 3 years. All right, so there are infinite solutions to a differential equation, right? Because you can always put the plus c on there and c can take on infinite values. If you want a specific solution, a particular plus c, you need something called an initial condition. You need some extra piece of information to figure out what c you want. So I have one here that y of pi equals 1. So I already know my general solution to this differential equation is y equals sine x minus x plus c. And then they gave me this extra piece of information, and I can use that to figure out what c is. So I'm just going to replace all my x's with pi's, my y with a 1, sine of pi minus pi plus c. Now c is the only unknown and I can solve for it. All right, what's the sign of pi? 0. 1 equals 0 minus pi plus c. So when I solve for c, I get 1 plus pi. It's really tempting to circle that because you just finished solving something and like that's just your algebra background, is you want to circle it and be done. But that's not the answer. That's just the plus c. That's just the c that you were looking for. That's a piece of the function that is the answer. So you have to go ahead and write down your whole solution again. Sine x minus x, and then instead of plus c, put plus 1 plus pi. So a problem that is a differential equation plus an initial condition, you're given two things, that's called an initial value problem. All right, so a little physics that probably most of you are familiar with. Velocity is the derivative of distance or position. Yeah. And also, what else is a derivative of something? You got it, yeah. Acceleration is the derivative of velocity. So this relationship, position, velocity, acceleration, we can use that to solve a lot of initial value problems involving falling objects or throwing an object. So suppose a ball is thrown upwards from the edge of a cliff that is 100 meters above the ground. So that means S of 0 is 100. That's its initial position. It has an initial velocity of 74 meters per second. So it's thrown with a velocity of 74 meters per second. So that means V of 0 is 74. So I've got two initial conditions, initial position and initial velocity. We're going to assume gravity is negative 10 meters per second squared. It's negative, that's not exact, but it makes it easier to do it in our heads. So I'm just going to use negative 10. We're going to derive the formulas for the object's position and velocity at time t. So you may already know what they are, but we're going to derive them using differential equations. And then we'll figure out how fast the object is moving when it hits the ground. Okay, so I know acceleration, that was given, right? Gravity A of t equals negative 10, which is velocity prime, the derivative of velocity, is negative 10 meters per second squared. So that means that velocity, which is the antiderivative of acceleration, right? Because acceleration is the derivative of velocity. So velocity is the antiderivative of acceleration. What is the antiderivative of negative 10? Negative 10t. And then we need the plus c also. Negative 10. Yeah, well, we're gonna use the initial to figure out plus c. All right. So now we have a formula for velocity. We need to know plus c. So v of 0 I know is 74. So let's see, I'll put it over here. V of 0. That means if you replace your t with a 0, you get 74, which means c is 74. So my actual velocity function is negative 10t plus 74. All right, so now I know velocity, and so I'm going to derive a formula for position because I know that position is the antiderivative of velocity. So S of t, my position function, the antiderivative of negative 10t would be negative 5t squared. Antiderivative of 74 would be 74t. And then you need the plus a constant. And then to figure out what that constant is, use initial position, right? I know I was given that S of 0 is 100. S of 0 would be -5 times 0 squared plus 74 times 0 plus C equals 100. So that means C has to be 100. So my final formula for position is -5t squared plus 74t plus 100. So that's my position function and my velocity function that I derived, only knowing the fact that the acceleration of gravity is -10 meters per second per second. And now that I know the position function, I can use it to answer the question. Actually, it's the velocity. I need both of them. I want to figure out how fast the object is moving when it hits the ground. So I have a function that tells me how fast the object is moving at any given time, right? So I have to know at what time it hits the ground. How could I figure that out? When what's equal to 0?
Yeah.
Distance or position, yeah. Okay, so I need to figure out what time it hits the ground at. So I've got -5t squared plus 74t plus 100. When does that equal 0? Because that would be the object is on the ground now. Because S of t is position above the ground. So just in case anyone's unfamiliar, I'm going to solve this using Wolfram Alpha so you can see how handy a tool we have at our fingertips. Okay, so we just search Wolfram Alpha, click on the link. All right, and then my equation is -5t squared plus 74t plus 100 equals 0. And it's going to solve it for me. So there's my two solutions here using the quadratic formula. Will it give me decimal approximations? It says approximate what? Ah, yeah. There we go. -1.2, which doesn't make any sense because we're talking about time. And what happened before we threw this object into the air, we have no idea. So ignore the -t. And it looks like approximately 16 seconds after we throw it, it hits the ground. All right, so we get t approximately 16 seconds. All right, so that is the time that it hits the ground, but the question that we were asked is what is its velocity when it hits the ground? So I need to take the velocity at 16 seconds. So -10t plus 74. -160 plus 74. Oops. -160 plus 74. -86. And its velocity, my units for velocity are meters per second. And does it make sense that this number came out negative? How come? Yeah, the velocity has direction, and this is a falling object moving down, so its velocity should be negative.